And welcome. My name is Andrew Dunkley, and I'm the host of the spacenuts podcast. And it's so great to have your company here for episode 300. Count them. 1, 2, 300. Wow. We can't believe it. Fred can't believe it. Marnie can't believe it. The pets can't believe it. Before we get into the show proper, I'll just explain a bit about what's going on. We've got a couple of segments that we've set up if we need them, but we are going to encourage questions via the webcasts on Facebook and on YouTube. And Hugh, back in the studio, is going to be keeping an eye on those for us and firing them through to me, and we can just ask Fred ad hoc questions, which he absolutely loves. Don't you, Fred?
Yes, especially when I know the answer.
Well, we'll make it up if we don't know.
Well, they always do anyway.
Generally how it works, yes. And Marnie is here to do the interview proportion of the show, and that's how we're going to get started. So if everybody's ready,
yes,
we will hit the magic button that only works 1 in 3 occasions.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space nuts.
Astronauts report it feels good.
Hello again, and thank you for joining us on another episode of Space Nuts. It is episode 300. Oh my goodness, can you believe it? I can't even count that high. But here we are, and it's so good to have your company. I'm Andrew Dunkley, your host, and joining me, as always, is the good Professor Fred Watson, astronomer-at-large. Hello, Fred.
Hello, Andrew. Episode 300. Who would have thought it?
I know, and it's so hard to believe. I nearly didn't make it, Fred, because one of my colleagues at the radio station has called me on the weekend and said, I've got COVID, Andrew, just thought I'd let you know.
Oh, no.
And we work closer together at the station than anybody, so I've been on ready alert. But so far, so good. But that doesn't mean much, does it? But look, I'm here, and that's the main thing. Now, Fred, we've got a lot to get through today. We've got bloopers, which came from the audience, a request for bloopers. We have got a question that is going to result in prizes for people, which we will do right at the very end because, you know, why wait? Why do it now when they can all rack off after they've put their answers in? So we'll do that at the end. That's called a hook. And there's a couple of topics we might be able to discuss pending the live question scenario. And, of course, we've got an interview segment. Would you like to introduce us or reintroduce us, because Marnie's been on the program before, to our interviewer extraordinaire?
Well, our interviewer extraordinaire just happens to be somebody who's sitting not in the next room to me, but about 3 rooms away. That's right. Who knows both me and you very well. She knows me better than she knows you, Andrew, as you might expect.
She doesn't want to know me.
No. Well, we weren't going to say that. So Marnie and I have been a team for 15, 16 years now, and we do all kinds of exciting things, and Marnie is the mastermind behind all that. Her background is in travel and events, and so we have travelled all over the world taking science tours to some of the most exotic places and had a ball. And in some of the places we go to, we come back with COVID-19, which is what happened on the last tour. You get, look, our tour groups get every facility that you might want. So we thought it would be brilliant if Marnie was able to partake in episode 300 and to put the screws on both you and me in terms of difficult interview questions, ones that we perhaps would hope nobody would ask.
Didn't know I was going to get raked into this. So, I'm usually the one asking the questions, you know that.
You are, that's right, yeah. Well, it's my way of getting my own back on you. So, ladies and gentlemen and boys and girls in the listening audience, let me introduce to you Ms. Marnie Ogg, the Executive Director thing of the Australasian Dark Sky Alliance and Dark Sky Traveller.
And conversation podcaster.
And yes, Dark Sky Conversations podcast. So she's got the Dark Sky Conversations T-shirt on.
I did.
And it does say thing on a business card too.
That's my official title. And I have to say how delighted I am to be here with you gentlemen today as your backup guest after your very special guest. It is a real honor to be the backup, yes.
We had 2 dropouts, so you were third string.
Okay, thank you. That makes me feel very, very privileged.
Well, we thought we'd get this off to the adequate start that we're all used to.
Well, you may as well start as you finished, yes.
Yes. Yeah. Well, it's over to you, Marnie.
Yeah.
Hit us.
So, well, that was, I have to say, congratulations. 299 episodes ago and probably a couple of months before that, Fred came to me and said, Andrew Dunkley wants to do this podcast. And I said, why? It'll never work. You'll never get an audience. No one will listen to you. You've got better things to do with your time, Fred. But the question remains, why? Why did you do it? So, Andrew, I'll throw that to you.
I used to interview Fred every week on my radio show when I worked for the ABC, and it was one of the most popular segments that I did. You can do the hard yards with the politicians and all those other people in your program and talk turkey about the economy and all that stuff that really excites me and puts a breakfast audience to sleep. But more people would ask me questions like, and you're going to love this, they'd say, is Fred really as nice as he sounds? No. It's true. That was the most common question, and it was the most popular segment, even though if you ask Fred a question, you can sit back and relax for 20 minutes until he finishes the answer. But that's and when it came time for me to move on and, left Fred swinging in the breeze, I ran into Hugh one day down in Sydney, who also left the ABC around the same time as me, and said, what are you up to? He said, I've started a podcast company. I went, oh, interesting. What are you looking for? He said, anything and everything. He said, have you got any ideas? I said, what about Fred Watson? And his eyes lit up. And that's kind of how it happened. Because it was such a fun thing to do and it was so popular, I thought it would translate well into a podcast. And so we bit it off and we've been chewing ever since.
Yeah, no, fantastic.
Well, we're seeing how it, just seeing how it goes.
See whether, still in test phase.
See whether it's worth keeping going.
Yeah.
Well, don't listen to your wife, Fred, because she's got no idea. Yeah.
Well, we're just taking the same approach as Virgin Galactic. We'll lift off eventually.
Eventually, yeah. So I guess that kind of leads me to the next question. Most some podcasting school, which of course I haven't attended, and I don't think you have either. Most people talk about the conversational style working. That obviously works between you guys. You banter backwards and forwards. But I want to ask the question: how many times have you actually met face to face to do the podcasts, or even in real life?
To do the podcast, we've been face-to-face once in 300 episodes. Fred just dropped into Dubbo one day and came to my office and we just recorded it on my work desk through the computer, sharing a microphone, old-fashioned style. But no, only once. And how many times have we seen each other face-to-face in 25 years, Fred? Probably...
It would be half a dozen, probably.
Yeah, it would
That's
be.
about it.
Would be.
Because Andrew's been, when you were connected with the ABC, you were kind enough to act as MC for some of the events that we put on, particularly the Alison Levick Lecture. I remember in Dubbo one time with Penny Sackett as the speaker, and you hosted that. So we have done stuff together. Actually, I think half a dozen is an underestimate, because you might remember there was a period when I used to come into your studio every month to talk to Lisa Hampshire.
Yeah, that's right.
On mornings. We had an hour-long Q&A session, which resulted in the book, Why is Uranus Upside Down? That's where most of those questions came from.
How many questions did you get on that show?
Well, in the book, there are 148.
Yeah, I don't think there were that many.
There were great questions as well. And a lot of them, Dubbo, for our listeners, is in regional New South Wales. It's a town that is surrounded by a lot of open country, and a lot of people who live on the land and work on the land actually listen to that show. And they were the ones who could get out and look at the night sky and see it in all its glory. It was fabulous. Some of the questions we got, really detailed ones about, what they could see in the night sky. Fantastic stuff.
Just quick piece of homework. I understand we're having trouble getting out on Facebook at the moment, but we're working on YouTube. And thanks to Carrie Brown, who's put a link to YouTube on Facebook for people to switch over. So,
brilliant.
Yeah, apologies for that, but that's beyond our control.
That's
live radio is the same.
Yeah. So picking up from what you just said then, Fred, you were talking about the night sky in Dubbo and Coonabarabran, obviously, and my podcast is Dark Sky Conversations. And I asked people, where was the darkest sky you've ever seen and what it led you to. And look, let me throw it to you both. Fred, what was the darkest sky you've ever seen and where did it lead you to?
Well, you know about this one because I think I spoke to you on the phone afterwards. There was one night at Siding Springs Observatory. So Australia's national observatory. I was astronomer in charge there for 20 years. The biggest telescope, or the biggest visible light telescope in Australia. And on a very dark site. And it's a site that when the skies are clear, it's so dark in terms of the absence of artificial light that you can see by the stars. You can walk around easily by the stars. And in fact, we've demonstrated that the Milky Way actually casts a shadow on the ground. If you hold your hand out on a night when the Milky Way is blazing overhead at Siding Spring, you can see a shadow of your hand. But
on the ground.
On the ground, yeah.
How they measure the Bortle scale, just to interrupt?
It's one of the characteristics of the Bortle scale. That's right. A Bortle scale is a scale of indicators as to how free of light pollution your sky is. But the night I'm thinking of, I came out of the telescope dome, and we used to have, well, there it still is, but it's rebuilt now because the original one burnt down, a lodge, an astronomer's lodge where astronomers go to sleep during the day after they've worked at night. And it's a well-worn path for me. I knew I could find my way without any trouble. So off I set, and then very quickly realized that actually the sky was completely overcast and there were no stars. And I could not see a thing. I was fully dark adapted. I couldn't see anything. So I thought, well, I know it's this way somewhere. And then I fell off the mountain. I didn't hurt myself, but it was a salutary lesson. I stood up, had no idea where I was. There was just a glimmer of light coming from the doorway of the telescope because there was a safety light in there. So I made my way back towards that, went up to my office, got a flashlight and came back and did a repeat performance. That was the darkest night I ever remember.
Yeah.
You're very lucky if you were falling off that mountain. It's a heck of a long drop.
Yeah, well, there are bits of it that aren't that far. So the bit I fell up was only a foot or something like that. But it was a stupid thing to do, to embark on a trip like that without a flashlight. So I never did it again.
What about you, Andrew?
I honestly could not tell you. I know that's pretty lame, but I can't recall, because I've lived in cities for a long time and surrounded by artificial light. So I think probably when I was in Boy Scouts years and years ago, we did a hike to the top of Carey's Peak in Barrington Tops.
Oh, okay.
And there's not a shred of light. There's no civilization up there whatsoever. It's deliverance country. And, it was particularly dark that night because it was overcast, it was cold, it was, as it turned out, right next to a 100-foot cliff we didn't know was there. So it turned out the next morning we'd camped right on the edge of it and didn't even see it. So that was probably our darkest night, the darkest night I've experienced.
Yeah.
Two near misses there with darkness.
It was pretty near miss. Yeah, we had no clue, but it rained for the 2 days we were up there. And we just lived in flowing water because it was torrential rain in a campsite. It was about as much fun as pulling teeth, I think. But we still talk about it. I think the funniest thing was on the way down, one of my mates was desperate to relieve himself, and he did. And he wiped his bottom with stinging nettle leaves. Poor Andrew. Wasn't me. I'll never forget it.
Yeah. No.
Excuse me.
So we didn't get to see any stars there at all. It was just...
well, he probably did.
Yeah, he saw a lot. But, that would be the darkest night, I think.
Yeah, that's funny memory. Interesting.
What about you, Marnie?
Yeah. You dark skies aficionado, you.
Yeah.
Yeah, actually, I still think Siding Springs got some of the strongest memories for me, with taking groups up and showing them the night sky and walking through dark places and just thinking, people saying, "I need my torch, I can't do this," and it's still quite light. We've become very habituated to have light in our environment, even when we don't really even need it. I did think of a story, but I can't. Yeah, no, I can't think of one.
Oh, you could work in radio the way you forgot that.
Yeah, because what I was thinking of was to talk about the fact that, I would have thought that your interest and enthusiasm for space may have been started by dark sky experience, and because often when I ask my podcasters, that's what they say. They were attracted to their profession from it. So and then maybe what would you have done if you hadn't been doing Space Nuts podcasts and interested in space? What would have been your thing? And you talked about near misses, Andrew. Maybe it's golf.
I adore golf. I love playing. It really gives me somewhere to vent. But I would have done that anyway. But my first love is radio, and I just see podcasting as an extension of that. It's a similar process. It's really just a more casual approach to interviewing and dialogue between hosts and guests, and radio is basically that. And I'm still doing radio, so I'm still doing what I love to do every morning on top of a full-time job, on top of this, on top of writing books. The plan is to wind back sometime this year, but I just enjoy it so much. I don't really want to stop. Why stop doing something that you've been paid to do all your life that you love?
Yeah.
So
what about
I'll keep doing radio for sure.
Yeah. Fred, did you want to?
What would I have done if I hadn't been
doing podcasting?
Oh, well, as you know, the other great love in my life is music. And,
I thought you were going to say me.
After you, my other great love is music. And as you also know, there was a time a long, long time ago when I was well on the way to becoming an out-of-work professional musician. In fact, I was for a while I tried to fund myself through my master's degree. So that's what I would have done, I think, had I not been totally captivated by the stars and captivated by Marnie Og and dark skies and things like that.
Good answer, Fred. Good answer.
Yeah.
So I'm going to sort of wind this up slowly, but my question is, yes, the conversational style, your enthusiasm between you both, your ability to banter backwards and forwards all makes this a success and has driven you to the 300 episodes. But there's also the audience in this. So what part have they played? Is there a particular erudite question or someone in particular, or the most far-flung listener that you've had, furthest part of the globe, from Australia? What stands out in your memory with this wonderful audience that support you and make it happen?
I think it's the collective interest. They're all on the same page in terms of their interest in astronomy and space science. I love the fact that they are the people that have kept us going. If they hadn't got on board with us, this would have ended a long time ago. I also like the fact that they created their own Facebook page where they can talk to each other and share each other's astronomical photos or articles that they find interesting. The audience is also the group that came to us and said, well, look, we want to give back. We love what you do. We'd like to put some money into this, and created the option for people to become patrons. None of that was our idea. It was all audience driven. So I think that speaks for itself. Without the audience, without the people that discovered us and stuck by us, we would be nothing. So I thank them for that.
And the thing that inspires me, and they are inspiring our listeners and watchers, Andrew, is the complete. There's a wide range of the level of perhaps knowledge in terms of things in space and things in astronomy. But everybody feels able to put in their questions, ranging from really quite, almost basic questions to really detailed questions about the nature of the universe and, the constituents in it. And that is a huge range of interests and perhaps abilities in terms of phrasing, picking out what questions will be of interest. But there's a common ground to all of them. All of these people just love space and astronomy, and it shows, it radiates in the questions. And in that regard, I think Andrew and I have got a bond with the listening audience. Both of them, actually, not just one member of the audience, but both of them. No, we do know that we're very, very fortunate, actually, in having the number of people who subscribe to Space Nuts. It's staggering, and a great tribute to the people out there who've got a strong interest and who think it is worthwhile sitting down, whether they're in their car on the way to work or at work or at home, sitting down and listen to us for 3/4 of an hour while we ramble on about that stuff.
Yeah.
There you are.
Well, I have to congratulate you both. I think it's a marvellous effort. I think the audience is testimony to your ability to engage people, to pick up on each other's questions and answers and to work together. And I wish you all the best in the next 300 episodes. So.
By which time I'll be 105.
We'll have another cat.
We'll have another cat.
Oh, dear. Well, look, I hope it goes on and on and on, because it's just too much fun not to keep doing. And
it is a lot of fun, that's right.
Yeah, I think it's and during these last couple of years when things have been so bleak around the world, I've got messages from people saying it's just so good to get away from all that and enjoy something that I love. So I think that's really nice. Really nice. Marnie, thanks so much. Really appreciate you helping us out today for episode 300. Lovely to see you.
Thank you for letting me be third best.
No, you're the star.
Well, I'm so used to being third best, I'd share the love.
I'm going to jump off, so I wish you all the best.
All right.
Yeah,
thanks, Marnie. See you.
Thank you.
And you are listening to and watching episode 300 of the Space Nuts podcast with Andrew Dunkley and Fred Watson. Now let's take a quick break to tell you about our sponsor NordVPN. Now this is a service I've been using for quite a while now. I'm very, very happy with it. And I'm not just talking about their service. I'm impressed with their reliability and their speed, and there are certainly times when connecting via NordVPN is actually quicker than my regular connection. And there are many benefits to having a virtual private network. It does secure you against all sorts of nasties out there in the Ethernet. And you really do want a VPN service to keep you safe from hackers, especially when you're using public Wi-Fi. And the reason for that is quite simple. Public Wi-Fi is not absolutely secure. In fact, the encryption standards that protect most modern Wi-Fi networks are not secure or up to the standards required in the modern era, and they can easily be overcome by expert hackers. And there are plenty of people out there that know what they're doing and can get around these flimsy systems. So if you're using public Wi-Fi at any time, and that can be just about anywhere in the street, at an airport, railway station, bus stop, even in a public situation in a shopping centre, you are exposing yourself whenever you access it on your mobile device. Now, NordVPN has got you covered. You can set it up on your phone, on your tablet, on your TV, your laptop, your PC, anything that connects to the internet basically, and secure yourself. You can even set it up to turn itself on when you log in, and you don't even have to think about it. So check it out today. We have an exclusive offer. You can grab your exclusive NordVPN deal by going to nordvpn.com/spacenuts. Use the code SpaceNuts to get a huge discount off your VPN plan, plus 1 additional month for free, plus a bonus gift. It's completely risk-free, and Nord's 30-day money-back guarantee comes with it. So it's a great deal. It's well worth looking into, and honestly, I don't know where I'd be without VPN myself, with all the other benefits, not just protecting you from hackers, although that is a very big benefit in itself. Grab your exclusive NordVPN deal by going to nordvpn.com/spacenuts. Use the code SpaceNuts to get a huge discount off your NordVPN plan, plus 1 additional month for free, plus a bonus gift. It's completely risk-free with Nord's 30-day money-back guarantee. Now, back to the show.
Roger, you're loud and clear here also.
Space Nuts.
But you turn it on and off again, and it seems to be all right.
Yeah. Okay.
So
well,
hopefully that'll be good.
And my levels are all right?
You sound great, yes.
I know that, but my levels are all right. Oh, dear.
Bum-tish.
Yeah, one of the great moments, if there is such a thing on this show. Now, I want to encourage people to send us some questions without notice for Fred. So if you would like to do that, you can do that on the YouTube chat, because we're still having trouble getting Facebook to work. But I know lots of messages are being spread around on Facebook to get people to hit the YouTube link so that they can watch. And I know it's working because I'm looking at myself right now. And whatever I said 5 minutes ago is now appearing. No, it's not that long. It's just a slight delay. But we're getting questions. And got one straight off here, Fred, if you want to tackle it, from Kaz. Why is the Oort cloud a sphere and not a belt?
Ooh. That's a
an
good
all-round great question.
It's a great question, yeah. Sorry, I've just dropped my pen. I usually make a note of these questions so that I can kind of write them down later. Let me pick my pen up as he falls off his stool.
Here's this live radio scenario again. I could tell you a story about a live radio situation very quickly. I had a live guest once, and she was super duper nervous. I said, just relax, everything's fine. I'll ask the questions, you answer them. And, I'll take care of you. I always try to tell people that. Anyway, I asked the first question. She just sat there like this. And that was the whole interview. The very next day, not kidding, I had a lady in. She said, I heard that interview yesterday. Oh, that poor woman. I said, I know, I tried my best, but she was just too scared. And she froze. She said, well, I won't do that. And guess what happened?
She did.
Exactly the same thing. 2 days in a row. Anyway, you've got your pen now.
I've done it. I've written Oort cloud down on my bit of paper. There it is.
Why is the Oort cloud a sphere and not a belt?
It's. I think the answer is to do with where the Oort cloud came from, and that is that it's the sort of debris on the edge of the cloud of gas and dust that collapsed to become the solar system. And a great question that might be allied to this is the Oort cloud rotating? Because that's what makes things flat when they rotate. The gravitational interaction, with the fact that these objects are rotating, pushes them into a flat disk, a bit like the rings of Saturn, which are lots and lots of particles of debris. But the Oort cloud is so far away from the sun that whilst it is gravitationally bound to the sun, it feels the sun's gravity, and that's what stops it, fading away altogether. It's not so close that it actually gets this motion that essentially collapses it into a flat plane. I think the best way to think of it is just as a fossil remnant of the cloud of dust and gas that formed the solar system. And that's pretty easy to imagine. I mean, you might say, well, why is the sun spherical and not a disk? And that's because the gas pressure and the rotation all balance out. There's probably a similar story, but at a much, much, much lower level with the Oort cloud. It's stable as a sphere. But a great question, one I have never been asked before.
There you are. You might not have been asked this one either. Thanks, Kaz. Paul says Maxi J120 plus 070 is lying on its side like Uranus. Could it have been knocked on its side before it became a black hole when it was a star, like it was hit by another star?
Yeah, we talked about this object, didn't we? This is the one.
I think so.
Which got us into trouble with the semantics about, it's a bit acute like Uranus. That was the answer in that particular case, because its angle was acute, and the angle of this black hole's axis is tilted to the plane of the accretion disk. It is still a puzzle as to why that should be. But yes, maybe there was an impact of some sort before it collapsed to become a black hole. The problem is that the accretion disk the accretion disk really relates to the what you might call the equator of the star that was the star before the black hole. I would imagine that it's very hard to decouple the rotation of a black hole and make its spin axis anything other than perpendicular to the accretion disk. But this one is, and we don't know why. So I apologise for that garbled answer, but I think our listener's question is probably as good as it gets at the moment.
No, that's fine. Thank you, Paul. Board Broke Build has... That's a great username. How much gravity did it take to bend light? Or maybe how much gravity does it take to bend light?
Not much, actually. In terms,
that's the official answer.
The official answer is not much, yeah.
An adequate amount.
Yeah. The bottom line, the best way to put this into figures is if you think about the sun, which is a large object. Its mass is much, 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 much greater than the mass of the Earth, and it's a star. It's a kind of fairly modest-sized star, but it is still a star. The light that just goes past the sun and doesn't quite if you think of a star behind the sun, the light of that star just passing the limb of the sun, in other words, really close up to the sun, that gets bent through an angle of 1.75 arc seconds. And an arc second is 1/3600th of a degree. It's a tiny, tiny angle. And 1 3/4 of those is the angle that light is bent by due to an object with the mass of the sun. So that's the answer to the question. It really takes a lot of mass to significantly bend the light, to significantly bend a beam of light, whether it comes from a background star or wherever. And that's why the most prominent effects of what we call gravitational lensing, which is a result of this, of light being bent by gravity. The most obvious examples of it come from clusters of galaxies. That's where the bending is at its most, because they are the most massive objects in the universe. A mere star like the sun bends it through 1 3/4 arc seconds. That was the angle, by the way, that was measured by Eddington in the 1919 eclipse that demonstrated that Einstein's theory was correct.
Okay. Now, I have a question from Dipper. Where do we go when we reach the limits of our solar system? Mars, moons, then where?
Do you mean, I guess, in terms of exploration?
Well, I think in terms of of the geography. Or maybe it is human limits. It doesn't really elaborate on that.
Yeah. So, because the solar system's big, it goes out to the Oort cloud, as we've already established. But where would, certainly in terms of the robotic exploration of the solar system, everywhere is the province of these robots, from Mercury, from the sun's atmosphere, in fact, with the Parker Solar Probe flying through the corona at the moment, out to the furthest object that we've ever visited, which used to be called Ultima Thule and is now called Arrokoth. That's funny little, well, it looked like a snowman, but it's actually two disks joined together, way out beyond the orbit of Pluto. So all of these places have been explored robotically. But in terms of human exploration, well, Mars is clearly number one in terms of it being the most similar object in the solar system to the Earth. It is still dramatically different, but it's the most similar object, and probably the easiest for humans to actually get onto and walk on. But I think, yes, the moons of Mars are other places that might actually be intriguing for human exploration. And in fact, a number of people have suggested that the biggest moon, or the bigger moon of Mars, Phobos, would be a good staging post for to mount a base from which to explore Mars, because it's a lot easier to get a spacecraft to touch down on an object like Phobos, which has got virtually no gravity. I can't remember the figure. If I remember rightly, the escape velocity on Phobos, I think it's 43 kilometers per hour.
Oh, you could get off on your push bike.
You nearly do it on your, well, that's right, nearly do it on your push bike. In fact, yes, I've exceeded that on my push bike. I've been up to 50 on mine, yeah.
When I was 16, I couldn't do it now.
No, yeah. Anyway, yeah, so I think that's a really good suggestion. I'd love to see people walking on Titan, Saturn's moon Titan, with its lakes of frozen hydrocarbons. But imagine the spacesuits you'd need to keep you warm in a surface temperature of minus 190 Celsius.
No, thank you.
No, I don't think so either.
Now, David's got a very short and sweet question. Do photons actually have a colour?
Well, yes, in relation to their to the energy that they carry, and I mean, if you grab a photon, it doesn't have a color; it's just a packet of energy. But it's the wavelength of the light that the photon represents is what gives it its color, and I guess that's very much to do with the way we perceive color. So I think, but I think that's a lovely question. Do photons have color? Yes, in terms of how we understand them, I think they do. They might not be very vivid colors, but they nevertheless represent colors.
Okay, thanks, David. Kyle says, I've heard that the edge of the solar system is about 1 light year away, while others say it's more like 2 light years, meaning the voyages are still within the system. Yep. Which is more accurate?
There's no doubt that the Voyagers are still within the solar system. I think Voyager 1, if I remember, it's in the region of 20 light hours, something like that, away. So nowhere near light years yet. And yes, that figure of 1 to 2 light years is about right. It's that's the sort of radius, we're not exactly sure, but that's the kind of radius that we think the Oort cloud is at, something like 10 to 20% of the distance to the nearest star, which would be in the region of a light year.
That's a huge distance still, isn't it, though?
It's a monumental distance, yeah. So, well, the Voyager 1, the most distant human-made object, people talk about it having left the solar system, and it's not really the case. What it's left is the sun's magnetosphere, what's called the heliosphere, the region of the sun's magnetic influence. So it's crossed that boundary between the sun's magnetic influence and the general magnetism of interstellar space. And in that respect, you could say it's left the solar system, but physically it hasn't. It's got a long, long way to go before we can say it's left the solar system.
Yeah, there was a big song and dance about when it passed through what they called the heliopause, wasn't it?
That's right, yeah.
Because it made some weird sound in its transmission. And they went, oh, it's out of the solar system now. But it's
yeah. The trouble is, I think it was Voyager 2 that crossed the heliopause and then crossed it again and then crossed it again.
Because it wasn't a constant.
Because it wobbles, that's right. Yeah. The heliopause is a fairly bubbly thing. It's a kind of surface where magnetism changes, but it's not static, as the magnetic field of the interstellar space and the sun change.
Ben says, I have a question. With the increasing number of assets being deployed into space, how do we continuously monitor them all and retrieve their data, considering they are in constant motion?
Yeah, well, that's right. That's the job of, these various agencies that do exactly that. The radar systems that track these objects, the communication systems which are all over the world that talk to them by radio. It's a big operation, and there are international bodies that sort of oversee a lot of that, but much of it devolves down to national bodies and the particular commercial entities that are controlling these things. So it's a mammoth task, but it actually works. I think it's, oh gosh, I'm pulling numbers out of the air here. If I remember right, it's in the region of 20,000 objects that are tracked. These are things bigger than 100 millimeters across, tracked by radar. So to have a database of all, where all these things are is really important. And I might just add a comment here, Andrew. Sorry to ramble on about it, but
it's okay.
One of the things that astronomers are asking for from the space industry, in the light of these satellite constellations that are about to make a huge contribution to the artificial brightness of the night sky, astronomers don't want to have their exposures, their images, destroyed or interrupted by a satellite going through it. And if you've got that number of satellites, the key piece of information that you need, if you're going to, close the shutter while the satellite tracks through, which is one way of doing it, you need to know exactly where that spacecraft is within almost a few meters. Now, that information is not currently publicly available. So it's a big ask of the space industry to make that sort of data, or those kind of data, available to the astronomy community and probably the general public at large.
This next question from Honor dovetails into that nicely. Will the next generation look up at the night sky and see thousands of satellites and space junk travelling across the sky? What is being done to get rid of space junk?
Well, that's the $64,000 question, the sting in the tail there. What's being done about it? Yeah. And really...
it's actually quite a contentious issue.
In many ways it is, because, if you think of ways to shoot down bits of space junk, that could be seen as a belligerent act, and suddenly you've got all kinds of international issues at hand. So what is being done is that if you're launching spacecraft now, you've got to have a way of bringing them down, basically. And that might mean that it's just in an orbit that will naturally decay within 4 or 5 years, which is what Starlink is doing. The SpaceX satellite constellation, Starlink satellites, I think, have a relatively short lifespan. So their orbits will decay. They'll drop into the upper atmosphere. They'll burn up harmlessly, and that's the end of that. But there are many, many more spacecraft that are a much bigger problem. They're in higher orbits. There have been a number of experiments that you and I have talked about several times, Andrew, about how you might send, sweep up satellites up there to try and grab things, either with some of them have got grappling irons, some of them have got nets, some of them are magnetic. Harpoons, yeah, there's a harpoon was one of them too. Different methods to try and grab spacecraft. So you kind of put a brake on it, so it naturally then decays, its orbit decays into the atmosphere.
Yeah.
But the first part of the question is a really interesting one, because that's really what faces astronomers in the next 10 years. We expect there could be as many as 100,000 satellites in orbit around the Earth by the end of the decade. Now, both OneWeb and SpaceX, with their Starlink satellites, both of those have taken steps to basically put them below naked eye visibility. So when they're in their normal operational orbits, you won't see them. SpaceX, because they're fitted with these visors, the visor sats that shade the sun. OneWeb, because they are actually at, I think it's 1,200 kilometers, their orbital height, which makes them faint. But there will be satellites which are transiting between their operational orbits and their launch orbits or re-entry. And there could be several thousand of those which will be visible to the naked eye at any one time. So it's inevitable that we're going to see more satellites with the unaided eye. Now, astronomers see them all the time. That's the big issue for astronomers to face. The good news is that I think the space industry and the astronomical community are talking. On the 1st of April, there was a new International Astronomical Union Centre to deal with this that was formed, which we watch with great interest as to how they proceed.
All right. I think we'll take a breath.
Okay.
And then do you want to just tackle one of the topics that you offered for this week?
Why don't we talk about the moon? Yes.
Yes, indeed. All right. We're going to take a little break. It's only going to take a few seconds from Space Nuts episode 300.
300.
0G, and I feel fine.
Space Nuts.
All right, I'm just doing a test to see if this is recording. Testing 1, 2, 3, and I can see a waveform. What about you, Fred?
Well, I have my own waveform. I carry it with me everywhere I go.
It's certainly not on your head.
Thank you and good night. Oh dear. What a crack.
If it's not your age that I'm having a crack at, it's your hairline. Not that I can talk.
No, well, you're doing better than me, Andrew, but you're still a way to go yet.
Yes, I suppose. My dad's still got a full head of hair and he's 84, so I've got my hopes up. Now, let's get on to this interesting topic about the moon. We're going to talk about the differences between the moon's near and far sides. Has something come up in the news of late that's reinvestigating this?
Yeah, there has. And, of course, this has the effect of giving the lie to what I said in Space Warp. No! As soon as you write a book on science, it's out of date because so much is happening. I think, if I remember rightly, there's either a section or a breakout box about why the moon's near side and far side are so different. So the near side is the side that we're familiar with. We see all the grey areas, the maria. These are basalt plains, which resulted from volcanism probably about 3.8 billion years ago. But when you look at the far side, as was first done in 1959 by, I think it was Luna 2, the Soviet spacecraft that actually went around the backside of the moon and sent back pictures. It's nothing like that. It's a much more rugged terrain, lots of mountains, lots of craters, but very little in the way of these grey lava plains that we see so well on the near side. And so the theory that had kind of evolved over the last 5-6 years or so, and what I wrote about in Space Warp, is that the what's called the tidal locking of the moon. This is the process that makes it face the Earth continuously. That happened very, very early on in the history of the Earth-Moon system. When the two were probably only 100 million years old, and so what you've got is the lava world, which was what the Earth was like then. It was basically molten rock, very hot. And here's the moon very close to it, because it was much closer than it is now, facing this side. And that heats up the near side to high temperatures. And what that does is stops what you might call rock-making chemicals condensing onto it, the silicates, which would be vapor at that time. Yeah. You put a cold surface there and the silicates condense onto it, and suddenly you've got rock. So the suggestion was that the far side is much colder, so the silicates condensed onto that, and you got a much bigger build-up of the rocky surface. So the moon's crust, that's the bottom line, is actually that the moon's crust is thicker on the far side than it is on the near side. On the near side, it's so thin that it have lakes of lava on it. However, cut to April 2022, and we have a new theory which has come from lunar scientists in a number of institutions, principally in the United States, at Purdue University, Brown University, Lunar and Planetary Science Laboratory in Arizona, Stanford, that whole lot of institutions, including, of course, NASA's Jet Propulsion Laboratory. This theory links the thickness of the rock on the far side with another phenomenon or it's actually a feature on the moon, which has been known, again, since the early days of lunar exploration. On the backside of the moon, near the South Pole, is something called the Aitken South Pole Basin, which is probably one of the biggest impact basins or impact craters in the whole solar system. So very early on in the moon's history, something whacked that and created this basin that we still see. Now, what's happened now is that these scientists have linked the impact that created the South Pole Aitken Basin with the thickening of the moon's far side, because they've suggested that impact would have sent, as they describe it, a massive plume of heat propagating through the lunar interior. And in particular, that plume of hot material would have carried some of the elements that actually themselves produce heat to the moon's near side. In other words, you swipe the moon's backside near the South Pole with an impacting asteroid or something, and you get a success or a progression of elements within the moon's mantle, the moon's interior, that go up the lunar near side. And those elements, actually, they've got a rather nice acronym. They're called CREEP elements, CREEP being KREEP, and what it stands for is K is the potassium, REE is rare earth elements, and P is phosphorus. So potassium, rare earth elements, and phosphorus, it makes CREEP, and those CREEP materials apparently have according to this theory, have kind of gone up on the underneath the surface of the moon, but contributed to heating on the near side. It's a really interesting theory, which I like because it links this gigantic impact basin, the Aitken South Pole Basin, with what we see on the near side of the moon and the difference between the near side and the far side. So a lot of computer simulations have been done. Pretty well every simulation that these scientists did actually produce a thinner crust on the near side than on the far side, exactly as we see. So this looks like being a pretty credible explanation for for that mystery of why the far side crust is thicker than the near side crust.
Sounds like a rewrite is required for it.
Well, that's right. Actually, it's interesting. I don't know whether you know this, Andrew, but tomorrow this afternoon I'm heading down to Canberra because the National Science Centre, which is called Questacon here in Australia, tomorrow they're launching the book. They're doing an official launch of Space Warp, including putting it on a rocket, I think, and sending it up to do the real thing. But one of the questions I know I'm going to be asked is, what would you rewrite in the book in the light of present-day knowledge? This is exactly it. It's exactly
there it is. Yeah. Gosh. Yeah. All right. And we've had a misfire. I knew that would happen at some stage, but that's okay because I am organised for that.
Oh, are you?
Yeah. Oh, look, one of the things in radio is always have a backup plan. So here we go.
Okay, we checked all 4 systems and team with a go.
Space nuts.
And the analysis that has been done with the Hubble telescope demonstrates that we are looking back 13.5 billion years. I beg your pardon. Let me get the right number. 13.8.
Sorry, Fred. I'm going to stop you for a second. Oh, boy. I was trying not to cough, but it caught up to me. I just got to get some water.
Get some water.
I'll keep the recorder going. I can edit it later. Oh, dear.
Poor old Andrew's snuck out of the room. He's disappeared into the ante-room looking for water to quench his insatiable instinct.
It started as a tickle and ended up as a, I don't know what. But anyway, that solves that.
I've given the editor a running commentary on your...
Oh, have you? Oh, dear. The wonders of water. I feel better now.
Yeah. So I was distracted by your obvious distress and actually got the wrong number there. So I'm going to repeat what I said.
Okay.
Are we okay just to pick it up?
Yep, go for it. One of our rare moments where everything fell over. And they're not so rare, as it turns out. Yeah.
No. That was a classic. I have no recollection of that at all, Andrew.
Wow.
Struggle for life there.
I must have hacked it out at one point and just put it away because I found it quite by accident the other day when I was looking for things to add to the program.
To the blooper list, yeah.
Yeah. Now, we're fast sort of eating time. Do you want to do a couple of more questions before?
That would be lovely. Yes, please.
And I will give an email address right now because, as I said, there is a giveaway at the end. We've got a bunch of prizes we want to give out. It'll be a random selection thing in terms of the winners, but you have to email your answers in. So if you want to take note of this email address, and Hugh might put the email address up on the various platforms that people are watching on at the moment, but it's spacenuts@bytes.com. Now, bytes is spelled BITESZ, spacenuts@bytes.com. We will select random winners who answer the question that I will give you in a few minutes. So bear that in mind. So that's spacenuts@bytes, BITESZ.com. to send your answer in to Hugh, who will then randomly select winners of, it'll be T-shirts, mugs, maybe some stickers. And Marnie has kindly offered us tickets to Siding Springs Observatory to see the big telescope. That's only entry, so you have to get there yourself and find somewhere to stay. There's a tent out the back somewhere. But those are the options that are available. So we'll do that shortly. Now, where were we up to the questions? Chapo is wondering what's your best pick for telescopes to get started with this year, and any major astronomical events we should put in our calendar for this year. I can tell you I've had a look at the calendar for this year. It's a pretty ordinary year.
It is, yeah. There is a lunar eclipse, I think, in November.
Yeah, that's about it.
Visible from our part of the world. Of course, next year we've got a solar eclipse on the, if I remember rightly, the 20th of April, I think it is, it crosses land over a very, very short neck of land in Western Australia at Exmouth there, and I think it's already kind of fully booked out for accommodation and things of that sort. But that's the next big thing. It will be visible as a partial eclipse, of course, throughout much of Australia, but not here in the east, I don't think, if I remember rightly. So for telescopes, you're kind of spoiled for choice these days, and a lot depends on how much you've got to spend and what you want to do with it. If you are serious about trying to get some deep sky viewing, yeah, well, there you are. There's she's a ripper. Yeah, she's a ripper. I really like that telescope, Andrew. I think it's a cracking good value. I can't remember what you paid for it, but it was something pretty reasonable, and it is effectively, it's a 3-inch refractor, isn't it? I can't remember what's the diameter of the
90 millimetres.
90 millimetres, there you are. It's 3.5 inches,
yeah.
Which is a great size for a lens telescope, a refracting telescope. Do you mind telling us what you paid for it? It was
just under $400, I think.
$400, yeah, that's right.
Maybe just slightly over. It wasn't expensive at all.
And
very
Australian
impressed.
Dollars. So,
and I've bought an attachment for it so that I can put my SLR camera right into the tube and take photos directly through the telescope. It's fantastic.
Yeah,
and I've got to thank Sandy in Melbourne for all his help in getting me geared up, because I didn't know a thing about it. He's been really good.
So that's a telescope that uses a lens to form the image, which is just a personal preference. I really like lens telescopes or refracting telescopes. But you can also get really pretty good value mirror telescopes, and probably for the money you paid for that refractor of yours, you'd get a bigger, maybe an 8-inch. So, what's that? 200 millimeters, an 8-inch Dobsonian. And a Dobsonian is a very rudimentary reflecting telescope that's on a mounting that in the early days was just made out of an old wooden box with bearings in it. Now they're a bit more sophisticated than that. But they are really good for general stargazing. What they're not so good for is photography, because you can't actually track on the deep sky objects. You could certainly photograph the moon and planets with it simply by putting your phone up to the eyepiece, because there's enough light comes down, because they tend to be bigger in size. In many ways, it's just whatever your own preference is for the kind of stuff you want to do. For general sightseeing, a Dobsonian's really good. Shows up the planets well. You get some nice views of nebulae, especially if you're in a dark sky place. They're reasonably portable. You can hoy it in the back of the car if you want to take it somewhere where the skies are dark, and very easy to set up for a bit of informal stargazing. But as I said, if you want to do advanced astrophotography, then they don't have the right kind of mechanical structure to let you do that. But yeah, go for it. That's the main thing. The worst kind of telescope is the one that stays permanently locked up in a cupboard and is never used. That's worst.
That's it.
Kind.
Exactly right. I haven't had many opportunities lately because of the weather, but that's improving as I speak. So now I'll throw in one more quick question, and then we'll have to do the competition and wrap it all up.
Okay.
George, I assume it's pronounced George or Jorg. Why can we not see the bright centre of our galaxy? Shouldn't it be too intensely bright, or so intensely bright, being so relatively close to us in comparison to other galaxies of a much larger distance?
Fabulous question, and it actually comes down to the bane of optical or visible light astronomers, and that is dust in the plane of the galaxy. The galaxy is very, very dusty, and in particular, the dust blocks off our view of the galactic centre. When I was doing research on a particular class of variable stars that cluster around the galactic centre back in the 1970s, I was cursing this dust because it stops us seeing towards the galactic centre. If you're in a dark sky place and you look at the constellation of Sagittarius, which will be in our winter months, the middle of the year, summer months in the northern hemisphere, you see that the Milky Way is at its widest there, but there's the central part of it is largely blocked off by dust. So the actual nucleus of the Milky Way, the bit that is really where all the brightness is invisible to us. And in fact, what I was doing in my research, this is, as I said, back in the 1970s, was using some they were almost like keyholes in the dust. A couple of them discovered by a scientist called Walter Baade in the 1940s. They're called Baade's window. Well, there were a couple of them, and I was peering through Baade's window, trying to see these stars in the central region of the Milky Way. Now, modern day infrared telescopes penetrate that dust, so we've got a much better view of the centre of the galaxy than we had before. But of course, that's not with the naked eye. If the galaxy was dust free, we would have a blazing night sky with the Milky Way looking so gorgeous in the middle of the year. It would be very, very spectacular indeed. But it's the dust that stops us seeing it.
There it is. It's just dust.
It is.
It's just dirt.
Dirt, really, yeah.
Yeah. Okay, Fred, we'll end it there, but I do want to put this question out for people to email in their answers to pick up some prizes today to celebrate 300 episodes of Space Nuts. And the email address, again, is spacenuts@bitesz.com. That's BITESZ. I think Hugh has messaged that out to people. So you're in the running for T-shirts, mugs, stickers, and passes to Siding Springs Observatory to see the big telescope, if you so desire. And the question is this. Name 2 of Fred's pets that have been on the show. We will tell you that one was a cat and one was a rooster. So if you can remember their names, that's what we want. Name 2 of Fred's pets that have been on the show. Email your answers to spacenuts@bitesz.com. There you have it. And that's where we're going to wrap up episode 300. Thanks for all your support. It's been fabulous. We never thought we'd get here. Thanks for taking part in the live webcast today. We did have some glitches, but that's the internet for you. So hopefully we got through to as many who endeavoured to watch as we could. And, of course, we'll be back again next week with episode 301. Fred, thanks as always. Without you, we would be nothing. We really appreciate everything you do. Thanks so much.
And thanks to you, Andrew. Well done putting up with me for 300 episodes. Well done again.
That's the easy part, you putting up with me. That's the tough bit.
But well done to our audience as well. It's fabulous that people are that interested. We'll talk next time.
We will. That's Fred Watson, astronomer-at-large, Professor Fred Watson, mind you. And back to Hugh in the studio, who's been working his tail off to keep everything going today. So thank you, Hugh. Appreciate that and everything you've done for us over the last 4 or 5 years that it's been running. So amazing work. And from me, Andrew Dunkley, don't forget to visit us on our website, spacenutspodcast.com or spacenuts.io. Keep those messages. Sorry we couldn't get to all the questions, but feel free to message them through to us on our website. We'll pick them up later, as we will the stories we didn't get to go to today. But thanks again. Lovely to have your company on this, the 300th episode of Space Nuts. We'll see you soon.
Space Nuts.
You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.